Hi, I'm course 11.5 from YUMIN Primary School. This lesson is Differential Equations. Chapter 1, Separable Differential Equations. So for this we'll still at ODE, which is the ordinary differential equations. So first let's revise last time what we have studied about, well, the physics. Okay, so last time we studied about the primary school speed. And this speed, it is the distance divided by the time taken. So for this, remember, this is the average speed. Well, one thing that you might get confused with the speed is the velocity. Remember, velocity is the displacement over the time taken. Remember, for those like taking PSLE, they get confused with average speed and average velocity. Remember, they are different. Speed, the average speed we learn it in primary school, while the average velocity is in secondary school. Well, in secondary school, we actually have E-math and A-math. So for E-math, remember they don't have that vector. And they write it as this limit delta t approaches to 0. Here we can have delta s over delta t. And so this is ds dt. Well, for A math, it is actually that we have the vector. So this is the limit delta t approaches to 0, and this is delta r vector over delta t. So it is actually a dr vector over dt, like this. Remember, this is average, but this is what we call it instantaneous, which is just right at that moment. So for this is only up to secondary school, but remember, this is not our main focus right now. What we really need to know is about acceleration. So for this acceleration, here is a limit delta t approaches to 0. So r here is for v. So actually v is for a. Like this, and then for this it is actually, well, we can write it in another way. Like this. Okay. So next, okay, what if we remove our vector, like one dimension? Remember, one dimension is actually a special case. So this, which will have our delta v. So we can actually write it like this. Okay, so remember acceleration, after that it is the velocity, and then it's either the x or the r. X is for one dimension, while r is for those vectors. Okay, so remember for this case, which is a particle traveling in a straight line, Well, if it travels in a straight line, so basically it is just one dimension. So it's actually this case. It passes a fixed point, O, with a velocity of 4 cm per second. That means this particle, when it passes this point O, is traveling at 4 cm per second. Its acceleration, A, the acceleration after it passes this point O is A cm per second square. It is the A equals 2t plus 1. So this t is according to our time, which is actually per second. As here is said, t is the time in second after passing this point O. So we need to calculate what is the velocity after 3 seconds, and what is the distance from O after 3 seconds. So for this first part, well, for the first part, we know that the A is actually dv dt. So we just use this dv dt. And this is actually equal to 2t plus 1. So for this, well, we can move the dt to the other side. So like this, we can on both sides use the definite integral. Remember, you can use the indefinite integral for most cases, but if you want it to be fast and quick, better to use definite integral. So that later you don't need to go and find what is that c, the arbitrary constant c. So for this v, well, here it said that v starts from 4. And then the t time starts from 0. So v, when does it end? Don't know. So this t, we already know 3 seconds. 3. Okay, so here is our v. Minus 4 is actually plus 4 over here. So for this plus the 4. So this is actually the 9 plus 3 plus 4, which is the 16. So remember, for this is our velocity, which is centimeters per second, like this. So that is for our part A. So next we can have our part B. So, next for our part B, remember, we need to find our distance. So, well, for our distance for this, remember, we can also use this part. As it said here, v is actually the t squared plus t plus 4. First, we'll need to check. Because at some time when it stops there, it might go back. So we must check whether it went back. Well, this actually looks familiar to you because that it is the quadratic formula that we have been using for a lot of times. So for this b, this part, which is our 1, minus ac, which is our 16. So this is a negative 15, which is smaller than, well, is this smaller than 0? So when this is smaller than 0, it means it never go back. So when it never and then add the extra parts. Okay, so for this, so x, we don't know what is that. Remember, x is actually our distance. Then here is our, so this is a t squared plus t plus 4 dt. This time is from 0 seconds to 3 seconds. So we actually just need to solve this equation, which here obviously is an x. So like this, and then we can sub this in. So it's actually like this. So this is our answer for part B. Remember, for these cases, you need to check whether it goes back or not. Okay, so it is actually just like this. It's just that the hard part is the acceleration part. Okay, and just remember that last time for this part is actually a 0. That is because the starting is actually 0 cm per second, but this time it starts with 4 cm per second. Remember, this starting velocity, we can write it as like this. It is the same meaning. Okay, so well, that will be the end for this time. So we'll see you in the next lesson, and if you like our videos, don't forget to subscribe to our channel. So see you in the next lesson. Thank you for your watching.